All right. This part is important about the project. Because so you need, as part of the scoping, to figure out what you want to build, how you want to build it, and among yourself, figure out what's your strength. Like maybe one of you says that I'm really good as data engineer, so I can work on the data pipelines. The other one says that I'm really good with model deployment, model development. So try to break it down. But that doesn't mean you should be like working as an individual. So everyone needs to know about everything that's going on. So that you need to learn this. This is actually building something that you could put on your portfolio. So over the last 2 years, 4 semesters, we had 5 startups from this course, in case you don't know. One of them today, they will have a demo. I don't think they are here yet. They will have a demo because we are going to use the platform in this class, right? So that should tell you the idea could actually work towards something, okay? It's not just, it's not a project, it's an actual product. So that's what I'm telling you. Try to be really careful about what you pick, if it is your interest or not. If it's not, just don't do it. Pick something else, join another group. Okay. So as part of the expo, the way that every semester we have been doing it is that when we come to your table, you get, if you have 5 members, you get 5 questions. Every person get 1 question. You have 6, maybe 6 questions. And that goes toward your grading also. So if I come to your table and you're like, I did the data part and I don't know anything about the rest of the pipeline, that doesn't work. It shouldn't be individual work. It should be teamwork. You could put the most effort on that, but you still need to understand how the rest of the pipeline works. Okay, so that becomes really important for all of you. Is that clear? All right. So that's your final project, and we will talk about it more and more as we go through the semester. Okay, this is something that will keep come up. Now, that's a typical grading. To be honest, we haven't had any team that, but most of the team normally get A because the projects or the product is pretty good. You only get something else if, I don't know, you come to your product doesn't have a certain pipeline. Like you deployed it, there's no monitoring, there's no retraining and stuff like that, right? So every component that we describe or we basically teach you need to be part of your product. Okay. Now, when one other thing that's really important is we also unfortunately have problems that, because teams are normally large, like sometimes 6 students, that team members complain that certain player didn't do anything, you know. That what we have been doing is that, so you have a Git, right? We look at your commit history. If your team says that you haven't done anything and the commit history shows that at the beginning you create a README file and that's it, you created a README file, okay? And that unfortunately happens. If you join a team and you want to work together, you need to also put the same effort, okay? We don't do that by default unless the team basically all come forward and says that, hey, we have issues with certain players. If you have issues, try to fix it early during the semester. Don't wait to the end of the semester and just bring it up. Okay, just let us know and we will try to either swap that team members, like maybe they want to work on a different project, or figure out basically what's going on. Okay, so when it comes to software requirement, you need all the labs basically required Python 3 AI.8 and above. We work a lot with TensorFlow, basically, and we actually have added PyTorch also for certain things. I'm personally a TensorFlow user, so that's why the labs are in TensorFlow. But anything that is taught in TensorFlow, the equivalent in PyTorch will be pointed out. Okay, this is the equivalent. If you're a PyTorch user, you can use that in PyTorch, basically. Okay, so that's your choice. Even if you do a lab and the lab is in TensorFlow and you're like, I want to do it in PyTorch, it's your choice, do it in Python. Okay. So that doesn't impact them. And then you need to have certain softwares that we will tell you how to install or where to get those later. So again, this was the MLOps Innovation Expo that we told you. This will happen. What will happen? Normally, what we also what you could do, if depending on how heavy is the event, we might also ask you that create a short video instead of we asking you a question, because we might not be possible for us to go to so many students and ask one question from 160 questions, 160 students. So we might ask you that to create a video, and every member basically talks about what they developed in that video. So that could be a solution which we will figure out as we go. All right. So I highly recommend you to read this. Academic honesty, I definitely recommend you use ChatGPT or whatever AI you're using for debugging. It's better than reaching out to me and your TAs. I use the same thing. So if you have a question, first ask whatever AI tool you're using. If they cannot fix your debugging, or then reach to us, because definitely the first thing I do, copy paste and put it there. That's what it does. Okay. So, but what is academic honesty in this course means is that you can't pick someone else's idea. Someone built something, deployed it, and just bring it and say that we did that. Right? So it should be your idea. Unique means that, well, think about this. How many of you have worked in the startups? All right, so some of you have worked. So the way that basically, if you want to build your own startup, the idea is that you either pick something that no one has built it, and you go with that idea, or you pick some idea that other people built it, but you make it either better or cheaper, right? So that's the idea. For you, you could pick a topic that maybe it exists already, but you're like, I have an idea, we have an idea, we want to make this part better, right? And we're going to prove this is better. Right, so your focus will become on that certain thing. So you need to figure out what you want to do, but it should be unique. Cannot be basically everything just comes from someone else's project. Okay. Now, where you get the data and everything is totally up to you. Okay. Your project, your idea, you need to figure out the data. We don't have data source for that, right? So before making decision, also figure out as part of the scoping, can we get the data for this? All right, so that becomes another thing to remember. A student accommodation, definitely review this. We will basically follow school rules for that. Diversity inclusion, the same, Title 9 or Title 10 at this point. And the guest lecturer, actually, this will be updated. So we will have 4 guest lecturers this semester. 2 from Google, 1 is Ben, and then we have 1 other. I'm not going to name, but we'll see later. Then that's my email. If you want to reach out to me, I have my student account here also. My student account, the email is reverse, mohammadi.r. So if you send me an email and you see I don't respond, check it. You're definitely sending it to a wrong. They both have same image also. Okay, so use this one. Okay, so or you can click on the image. It tells you that student or faculty. So choose the faculty. Office hours, basically, they will be announced. Hopefully, within the next 1 or 2 days, TAs will announce the office hours. Some office hours, at least for the first months, 2 office hours will be online, 3 will be in person. But moving forward after first months, because the types of questions normally we notice that it's can't be solved online, the office hours becomes in person. If you need, like you're working or something, you can't do office hours and you need a weekend office hours, you need to let your TAs know. We will accommodate for that also. Okay, so we always have done. Just let us know. Okay. And then again, this is the GitHub repository. Highly recommend you don't forget that and follow. We will post announcement on Canvas once in a while. Most of the announcement you will see on Slack, and contents will be posted to GitHub. And the videos, we have a YouTube channel, will be on YouTube channel. You will get the link to all of this. Okay. All right. Any question on the syllabus? Yes.
How strict are we on using the open source tools / models and build around the tools on that?
You can use for your product. Yes.
Okay.
You can use any open source model. Let's say You want to build an application, and this application, you basically download an open weight model, or you are using an API. Okay, you can also do that. Just remember one thing, that if you're using an API calls, you need to, as part of your scoping, as part of your entire product, do a cost analysis. And you say that, okay, I did this, but every time I make an API call, it's cost me $2, right? So what are you building? Like, this is like a super expensive, right? So you need to think about that. If you're just trying to make an API call, either you need to somehow make it cheaper, come up with some ways to make that API call cheaper, or maybe do alternative. Just download a smaller model, or a model that's open weight, and you deploy it yourself. We will learn about deployment of all these models. We actually will have labs on deploying one GPU model versus like a distributed GPU model. Right, so you will learn this. It's your choice to basically whichever you want to use. Also, you all will get some Google GCP credit from Google. We will be shared also. It's not that much, but it's kind of like, I think per team it becomes something like 300, 400, which is enough for deployment. So technically, the reality is that if you build something, don't test it on GCP. First, test a small version of pipeline on your local machine. Instead of maybe using Gamma, use like a Llama 3B, ensure the pipeline works, and then just replace the model component later as part of your deployment or final test. Any other question? Yes.
So as you said, if you're allowed to use some APIs, let's say some API for a modeling, Hugging Face, something like that, wouldn't we miss out on some of the things that we're talking about, that every team should follow model development, model pipelines? So wouldn't we skip over all those parts?
So that's a really great catch. So think about this. I have a piece which is a model, and you will see as part of the this is only different for LLM concept, right? Because in ML concept, you could do I don't know, like some neural network models, which doesn't have all this problem. But in LLM concept, you have one API call, but it's not that the answer doesn't end there. You need to have all sort of verification, prompt injection, tests, and everything in the model pipeline. So your model pipeline might be just an API call to get an answer, but how do you verify it? How do you check if it's correct, accurateness, citation, and all of this? So you need to actually build something around. So it's not going to be just an API call. We will talk about those.
So can you use GCP services for the MLOps? Like GCP offers Vertex AI, which takes care of everything, the ML pipeline, and it offers the infrastructure as well. Like,
Yeah, I think that's one of the reasons Google supports it. They want you to use that. You definitely can use Vertex AI. We will talk about this, but personally, as someone in industry, I will tell you that the more you become dependent of pre-built things, the harder it becomes for you to pass certain interviews. Because not every company actually wants to just work with Vertex AI. For some companies, the larger company, maybe they're in finance and they don't have that engineering something. It's okay, we just work with Vertex AI. But everything you do with it, the cost may be 3 times, 4 times more if you just do it yourself. And over time, that becomes a huge cost. Okay, you can use it. A student have used it over semesters, but it's just something to keep in mind.
Assuming we are going on the huge expo level, so what are the expectations on, based on the accuracies? Because we just talked about building yourself is better than relying on something else. So if there is a possibility, if we build something by ourselves, but has no accuracy, than using something else.
So that's really a great question. So I'm not saying that to build yourself everything. Like, you can build API call. That's totally fine. But the idea of the expo is that you build something innovative. It's kind of like if you go to, there's a CIC Cambridge every Thursday. There's every Thursday or every other Thursday, it has this startup events. But if you're into startups, I highly recommend you go over there, and you can go over there. People come demo their ideas, and they, just try to basically get feedback. And lots of time you see things that are just sort of like API calls, but the idea is what basically makes successful. It's not about I built something and I make API call. It's like what did you build, or how good is that, or basically I was saying. So you can do API call as long as it's something interesting. But if you just pick, also think about this, if you're just making a RAG pipeline, that's technically is not interesting, right? You can build a RAG pipeline in a day or two, right? So if you just the entire idea for you is that to build a chatbot, that's part of your labs. You have 2-3 labs on chat, right? So it should be something more interesting around what it does, who is benefits from it, who's you targeting, and how you're doing, and what's the importance of it. Right, so that becomes the idea. So how niche basically is the idea? Right. Okay. Any other question? We clear on the syllabus? All right, so that's great. So that was the syllabus. That's the expectation. Now we need to talk about a couple of things. One is that the attendance for this course is not mandatory, except for 4 or 5 weeks. Whenever you have project submission, so your project has due dates, data pipeline, sorry, scoping, data pipeline, model pipeline, deployment pipeline, monitoring pipeline. At that day, every team member should be in the class. Okay, that's the important thing. When you do have a submission for your project, every team member needs to be in the class. Just keep that in mind. The rest of the semester is not mandatory. Do it as you wish. The things that you learn. Maybe there's a week you're like, I know this topic or I know this labs, and totally up to you. I highly recommend you to attend, but it's totally up to you. Also, the days that we will have industry partners that they will come over here to teach you something, that becomes also mandatory. Okay. And you will see some announcement about whenever those in advance of basically what is the topic they are teaching, so you can also prepare. Like last semester, we had Ben, a friend of mine. Any of you is on the MLOPs community, Slack? Yeah. So there's a community, it's like on the Slack called MLOPs community. I also shared that link with you. Highly recommend you to join. There's lots of time. That's like from the entire world. It's like at this point, like 200,000 something members in it. They will post ideas and things that they're working on, the challenges. You can ask questions. So Ben is one of the founders over there. So he came last semester and he basically built a lab for this class, shared it prior to the class. The students worked with it, and he came here, demoed it, how you could improve your LLM pipeline by using something called BAML instead of YAML. Basically, BAML. It's like a different. It's technically, if you go on the website, it's written just a made-up language for elements. So, but we do something like that. We announce it ahead of time, and then you can basically decide if it's interesting for you or not. But we recommend you to be here for those classes. Okay, so that was about the syllabus, labs, attendance, and then the project in general. And we will talk about this more and more as we go. Now, so the thing about this class is that sorry, there will be lots of talking. Okay, there will be lots of talking because the way that the way that first time using this computer, I think that's can you all see the monitors? Phone size is good. Okay, so let's do feed. All right. So there will be lots of talking, and it's like a 3 hours class. So I highly recommend you grab a coffee, drink coffee before the class. I do it, but also if you do something on your laptop, that's totally fine, you know, with just and then at the end of the class, we will have, let me just jump at the end, we will have labs, for example, and this labs grows. So, for example, the end of this class, we will say that we're going to do these 2 labs, for example. And of next class, you have 3 labs and so on. And there are labs that I will do in the class to teach you to work quickly with certain things that is necessary. And then you will have a lab assignment to do yourself. And that's where you can decide if I want to work on this lab assignment or I will do as part of my 6th lab assignment, I'll work on something else. Also, end of every class, we have 1 paper, okay? And papers are not mandatory, but I highly recommend you to read if you want to get a better sense of the MLOps, LLMOps, and actually challenges that they have. So I highly recommend you to read the papers. Even if you use AI summarize it, just reads the summary yourself. You know, so just keep those in mind. All right. So this word, sorry. Okay, so let's just start with some, as part of the introduction, some deployment example. Okay. So imagine, the problem with this class is that I need to look up. Yeah, just here. Imagine you have this pipeline as manufacturing pipeline that you are developing, you're building cell phones. And as part of your pipeline, there's this convey that these cell phones are on it, and basically they go through it and you check for scratches on the screen. And your goal is that if there is some scratch to detect it as a defective, otherwise, you know, it goes through the pipeline. Now, as part of this process, you have a camera that takes a photo from every phone that is passing. And then you have some prediction server, basically, that prediction server exposes by some API. There is this edge device, basically. So edge device, the idea of is like, have you worked with Raspberry Pi, for example? You can use the Raspberry Pi, build your own small ML model, put it on the corner of your bike, for example, that records, and you can make a prediction for you who's in the, like an object detection, for example. So that's the idea of edge device. So for edge device, you need some software, you need a camera, and then you need to basically expose some API to the prediction server wherever your model, assuming that your model over there is in the cloud. And the model makes a prediction, it gives you the prediction answer back, and you have on the convey, you have a tool that says that a scratch, so push the phone away or keep the phone busy. Right? So that's an idea of deployment. Yes, it's making it problematic. Now, when you think about the this concept of phone, is there a scratch on it or not? You first question that comes is that, okay, is it actually a scratch or not? Like it's like a should be like maybe AI is like a looking at something and say it's a scratch, but you show it to a human and they say it's not a scratch, right? Is there agreement here that what's the definition of scratch? So basically, you can bring a human and you bring an ML model, and then they look at the same device and they make a call. Is it a scratch or not? If you see there's an agreement, then it's great. If it's a disagreement, that you need to figure out who's wrong, who's right. Like what was the reason for the disagreement? Right? That becomes really important because you all will do. Sorry, let me see why this doesn't have a full screen. Oh, full screen. So that's the part that you all need to figure out, and we will talk about this because at some point, most of you will iteration in your career will work on data labeling. Right? You all will do. I have done it so many times for so many years that it's like if someone tells me to do label data at this point, I'm like, no, I don't want to do that. It's really bad. It's you don't want to do it, but you will do it. You start to work at some company and they're like, hey, label this data. Right? That's unfortunate. Now, when it comes to the idea of like the machine learning production, this figure that what you see is called POC to production gap. The amount of time that goes to model development in actual production project is 5 to 10%. 5 to 10%, you actually will work on what you think is cool. I want to build a model. Maybe you, at some point during the project, you will actually do that. The rest of the time goes everything around it, from scoping, data, deployment, monitoring, cloud services, and everything like that, right? So the actual model itself is 5 to 10%. And this is a really interesting paper from a picture from this one of these papers that you will receive today, hidden technical debts. And that tells you that the ML code, the definition, and there's an industry agreement on this. That's the amount of time you will put on actually developing a model. The rest of the time majority goes to configuration, data collection, data verification, and stuff like that. Then it goes to machine resources, which is, okay, what are the resources I need for this, like a GPU, CPU, and stuff like that. Then you have this analysis, basically analysis tool, which is for verification. You develop the model, is it good, is it bad? You do some verification pipeline around. Then you have process management tools, serving infrastructure, and monitoring. And again, you will see even for you, what you are working is going to be only a small portion of your time will go to model development. Okay. That's unfortunate because lots of us, even I personally love to work most of the time on the model development, but that doesn't happen, right? Now, when we talk about the machine learning deployment workflow, you need to keep a couple of things in mind. You don't need to read everything like that, but it's basically going to be data management first thing. Comes from collection, pre-processing, augmentation, labeling, all of this. That's like a data processes. Then you have the model learning. Well, I want to develop a model. I need to select which model I want to use, and there are some hyperparameter tuning and stuff like that, which these days, it's not anymore manual. You just have libraries that help you with speeding up that process. Then you have the model verification and deployment. That's also basically has become much easier over time, especially for model verification. There are lots of tools that you can use to verify it's a good model, should I keep it or not? Now, the other aspects that you need to keep in mind is called cross-cutting aspects, which comes around the ethics, law, and user trust and security. Every time you work on these types of project, you need to keep certain things in mind. It depends on where you work. That might not be the case, but you need to keep the concept of ethics. Is this model fair? Does anyone know what's a fair model? When we say if a model is fair, what does that mean?
It's unbiased.
Unbiased. So what does an unbiased model mean?
I mean, if the results are not tending towards one specific class or something.
So when we say model is fair, think about this. Fair could come from so many things. It's concept of bias, like could be gender bias, a model that does better on a certain gender's data versus the other. Or it could be customer itself. So like one of the lawsuits that Google had like a couple of years ago in Europe that they lost a couple of billion was that the adding service was biased toward companies, larger companies or companies in the US. So if you basically search something, the top searches that always comes like a large organization, companies that are in the US. And if you are a seller with a small market, a small basically like customer base or a small service, your ad is always on 100th next page, basically, right? So no one will basically find you. So they basically we're biased even toward a smaller, or even regional bias. So those are types of things that companies these days, they are more careful about it because you can easily get sued. And I think if you saw the news, Google 2 days ago lost another couple of billions to Europe for similar story, right? In bias, basically in ad services. Okay. Now, when it comes to law, you need to be sure that you adhere to regional regulations. So in US, laws are different in states, especially when it comes around AI and data collection. If, for example, if you work with anyone in California, if anytime you apply for a job that is California based, you might see at the bottom of the job application, it tells you that I have this question that if you are from California, does anyone know why is that the case? So there's a law in California that if you're a California resident and a company has your data, you can legally ask them to remove your data from the entire system. You have control over it. So that's why the companies ask you if you are from there, because they need to put you in a different table. Right? No one asks you if you are from Boston. I remember I reached a company, asked them to remove me from the email list like multiple times. I wasn't successful. I still keep the spam emails. Right, so it doesn't work if you are from here. So that law is really important. The other thing is end user trust, right? End user trust means that do they trust the system that you have? And if they trust the system, is that trust actually really working? And it's kind of like people like a brand, it becomes like a brand reputation. Right? People like, oh, it's like, okay, this is a good brand. Even if they haven't tried it, because everyone talking about it, they go for it. That's basically the trust. Now, in concept of ops, this trust comes around usability, explainability, and user involvement, right? I don't want to name, but I'm not gonna name, but I joined the company last year. I left the company in 2 weeks. No, technically after 2 weeks of working, overall 4 weeks. Because this company was building something, and I joined the company, and I was like, so how do we do this? Like, well, we label the data this way. And I was like, well, how did we label it? And whatever they built, this product that they built, end of the pipeline, were getting fired. So they built something a company uses to detect if you are a good employee or bad employee. And I raised the concern, and I was like, this doesn't work. And the lead engineer on the project, the feedback they gave me was, oh, you're one of those engineers that care about explainability. That was a word. You're one of those engineers that they care about explainability. Then I raised this concern in another bigger meeting, the CTO and group. And they told me this: if user trusts our system, why should we care? All right. And that's where I was like, goodbye. That was Friday. Monday, I left the company. I'm not going to name, but you can find it on my list. So there are companies like this that you will work on it. It's your choice. You either work with it or not, you know. But the best example that I can give you is that for lots of you're international, right? When you get to a school, your application goes through some AI by default before it goes to other places. Now, think about if that AI system has some bias, or that AI system is not fair to you, toward you. What could that even 1% error impact on your life if you were part of that 1% error rejection? Right? Always think about it like that. That is small, as an engineer, you might say that it's just 1% error. But when you look at the bigger picture, what's the impact of that 1%? How could we fix it? So these are type of things that you need to keep in mind yourself. And that's why explainability is really important, because if someone tells you that why this person was rejected, you can explain it. This is the trace, these are the reason. But if someone tells you why this person was explained, it's like, this is a model we have, is a large model, it decided. Right? And there are lots of companies do that. It's kind of like a black box model. They think that there's no explainability anymore. And it's like, which is wrong. Even these days, the neural network, you can explain this and break this behavior down. Right? And then there's like a security concept, which it's pretty important these days. You can build a model, and probably you saw what happened with what was it called, the GPT and DeepSeek, right? So when DeepSeek came up, what did OpenAI do? They sued those, right? What did they say? They took our data by reverse engineering the model. They make a call, they get the feedback from the model, and then they collect that and basically try it, right? So that's possible. Reverse engineering is possible. So you either need to be sure that your model doesn't give out this where you need to basically have some workaround, which was funny in case of OpenAI because they took the data from other places. So these are things that keep in mind. The other one is that data poisoning, for example, especially these days when it comes to large language models and large models, you scrap basically the internet for data, right? There's a concept called data poisoning. What's data poisoning? Anyone can tell us?
To make the spam websites where actually, it's not like a real world, and then so if a company is crawling over the internet and then it crawls over that specific website, it dumps up the AI.
That's a really good one. So there's lots of websites online, especially for food recipes, that you go and this website, they have built it somehow. There is no traffic, right? So there's a website, but they reduce the traffic to minimum, like almost make it invisible. But in the website, they have recipes for food. And as part of the recipes, there's a link. Click on this to get the full recipe. So it's well written. It doesn't have a traffic. It doesn't have a bad score online as a spam. So when the basically companies crawl and collect the data, that recipe as a good recipe for food comes to LLM. Now, what happened was that these LLM models, basically, someone says that I want to make this food. They give you the recipe and the link to click on it. And user trusts that, and it's called data poisoning. You click on it basically and you receive a spam. That's an example. The other thing is that, so as part of the data poisoning, there's this, I think 2 or 3 individual, you can search it online in US. What they did, over time, they changed the data that exists online for insurance. Part of this scheme that they had was that they basically themselves as your insurance cost premium was the lowest as a cohort. Everyone else was normal. So this data collects, people use that data over time, and they were always receiving the lowest premium. And over time, and after a while, they figured out why this cohort always gets this lowest, and they saw that this was this data injection that happened, poisoning at some point. Right? So these types of thing happens, and these days companies they try a lot around the data collection. You might go across the entire internet, but the amount of good data that comes out of it is actually really small in compared to what exists on the web. So this is going to be the stages. Data management, you have collection, pre-processing, data augmentation, and then some data analysis or profiling that you need to do, okay? And we will talk about all of this in steps and in details, yes.
So do they manually go through all the collected data all over the internet and then, discard the non-good ones? Or?
You don't do that manually. So you have a pipeline for data verification, data cleaning. And this pipeline basically has different components. For example, checking for if it's a spam or not, if it's a link in it, verify what's this link. If there's a bad language in it, toxicity, a bias, and stuff like that. They have different, much smaller models, but lots of them that goes over this data and filter out what to keep, what to basically drop. Okay, so that's the idea. Now, the next one comes around model learning, and then here, becomes the model selection, training, hyperparameter selection, and what you basically want to do, which again, we will talk about this. And finally, we go to model verification. Now, I have a model, how to verify it, how to test it, how to see if it's a good model, should I keep it or not? And then you go to deployment, and deployment itself basically is a really bigger concept. It's going to be from where to deploy it, how to deploy it, what's the, am I deploying this to cloud? Am I deploying this on an edge device, like a cell phone, for example? You need to decide on the deployment strategies. And then how you monitoring and how to basically update it over time. And then this is the cross-cutting aspect, which we talked about. Now, what can go wrong in model deployment? So these are the things that are, again, we talk broadly right now, and then we narrow it down over time. First one is called data issues. And that comes around missing data, for example, a schema, bad schema, concept we have like called data drift. So you can hear you hear the term drift, especially in interviews. How do you deal with drift? And the idea of drift is that your data distribution is different at inference time in compared to the data distribution that you use during the training. That's a definition of drift. Now, drift could happen in the data distribution, could happen in the model output. What does model output drift means? That if you have a binary classification and you have a sigma, so you predict something between 0 and 1, correct? And technically, you have something like this. Let's just go for a while. Moving. So this is like a curve that you have, right? So this some like here in this region, some in this region, for example, and this, if this is 0.5, that's your classification during training. Now, let's say during the training, you figured out that only from here to here, only 10% of your data fail in the region which we call basically not confident. That's a region. Basically, if you think about the classification as a score and you define the threshold, above this 1, below this 0, you decide on that threshold. So when your model says something is 60% cat, 40% dog, technically your model doesn't know, right? Because that number is pretty close. So you need to decide where is the threshold. Now, let's say during training, 10% of your data falls here. Now, during the inference, over time you are counting, and you see that over time you have 20% data that falls in the region that your model says 40%, 45%, 55%. That tells you there is a drift in model's output. Your model, for lots of data, 10% or more, is unsure of the output, basically. And that could be a sign of there's a change in the data, or you need to basically update your model. Okay, so that becomes model drift, and you have a drift into output of your model that is not what you expected. Then you could have other, basically, like for example, leakage between train and test, the data leakage, or it's this idea when you have a large amount of. So one of the things that if you're reading on Hugging Face or following, you know that these days there are lots of conversation around that these scoreboards are not that valid because most of the data that used in training is actually as part of whatever it is in the scoreboard. All right, so lots of models get a really good score, but there's a data leakage. Like this data exists online. We all have the same amount of data. Right? So that's the problem. So that becomes data leakage because that means as part of the data that you use in the training is also as part of your test. And when you have a large amount of data, maybe you couldn't verify it. Then, so model issues that is basically, this is one part of it, but then you have overfitting on poor generalization, lack of interpretability. And these are all things that you need to deal with. Then it comes to training issues when, especially these days, you're going to deal more with that. Maybe a couple of years ago, this models quite like kind of smaller from the number of parameters. You didn't deal with a lot of like training issues like I'm running out of RAM or VRAM and stuff like that. I need a bigger GPU. Like I can't even load the model. I need to break it down. We didn't have those issues, but these days we will have. So it's like a training issues that are like kind of like models are harder to load and train. You need to basically ensure that your training pipeline is basically stable. And this incomplete convergence or premature stopping is when you have a definition of the stopping criteria, and your model stops, but is actually maybe it's a local minima that you were stuck. So that becomes a premature stop. Something to keep in mind. Then, when it comes to your deployment issues, it's like could be mismatch between your training and production environment. What does that mean? Let's say you have a big team. As part of you have a team for development and you have a team for deployment. And the development team basically use certain types of infrastructure. Deployment team, they are using different type of structure. And there was no proper documentation or basically environmental variables or environmental definition, right? There was no chart for how to deploy this. And you keep getting feedback that it doesn't work for me. I cannot deploy it. And you're like, oh, I can deploy it. And they're like, no, probably you have had issues like that at some point. You have a software and it's like, it doesn't work on my machine. It works on my machine, right? So that is when you have this lack of or mismatch between training and production. Then for example, lack of or rollback or lack of basically CI/CD support. Anyone here knows what CI/CD? So what's the benefit of?
You don't need to pipeline from scratch, and if you want to introduce new work into a model.
Yeah, it's basically a practice to speed up software development, right? You basically create a pipeline, and as part of this pipeline, when new code comes, it goes to part of the integration, CI, integrates, tests, verify, and then it goes to the next part, the CD, the deployment or development. It's at that part, it's like does the final verification and pushes the code to wherever it's supposed to. Right? By doing so, we speed up that process and we can detect issues earlier in the code PR versus sending it out and have issues later. Then monitoring and maintenance issues, if basically not having any alert for model degradation, that means that you detect something like that, or you don't monitor for it. And then you don't notice it. And over time, the performance keeps getting worse and worse. And then all of a sudden, you hear online that people like, this software or this platform doesn't work. It's not good, right? Because you haven't heard about it because you didn't monitor, right? So you need to monitor for that, and then you create an alert for it. We will talk about creating an alert and who should be at the end of what type of alert base. It's like an engineer alert, it's like a product management alert or something. All right. Now, this is an interesting thing we're going to talk about. Have you heard of this survivorship bias case study? All right. So you don't talk about it. Let's see if everyone knows. So during World War II, there was a study about airplanes that are coming back. Okay. And they basically look at like there are so many airplanes that will get shut down. They never reach that. Okay. So they did this study that, well, every airplane that's coming back basically have this, their wings is full of holes, right? So basically they were like, what we need to do is that we need to make the wings strong, like put more robust, basically metal type thing on, right? Because they were like, the other ones didn't come back basically, right? So this ones with all these holes, they came back. So we need to make it stronger, so maybe these ones were lucky. What do you think could go wrong? What do you think was the issues? What's the problem? What would you guess? Yes.
Might affect the aerodynamics of the plane. Fuel usage.
No, so let's ignore the plane. But what do you think the decision was? What was the problem with the decision?
Wings were not the problem.
So what was the problem?
Maybe the bullets were hitting the engine or something.
So let's assume that it's just what you see is wings. There's no bullet on the engine.
These are the ones that are coming back, right? So this is not the problem area they should focus on. The ones that were not there are the places that were not there. This is where they should focus.
So the problem was that every plane that's coming back, the wing was shot. But the wing thing was not the problem. The belly of the airplane was the problem. That's where you get shot and you didn't come back. So the one that are coming back, they were not shot there, right? So that's a really interesting case study. So they did change it basically. This statistician, they came and said that this is a bias from perspective of what came back was survival. Survived basically airplane. We should focus on something else. This, if you think about it for machine learning, if you always look at users that are happy, don't look at where you had actually silent error or issues, you never know what's the problem. You're always looking at everyone's happy. You don't look at where it's the problem. So you need to detect that, otherwise you will have these types of bias toward end user or toward basically decision making. So now let's talk about the steps of ML project and what you will learn in this class. So we will have 4 steps, okay, 4 main steps, and that's where also your project or the product that you built will focus on. Step 1 will be a scoping. Okay, we will talk about it, but scoping is to scope this idea. Step 2, it becomes data. So depending on the scope also that we work on, you will have a different time window for submission. Some like a scoping will have 2 weeks time frame. It's much shorter. When you go to data pipeline, you will have 4 weeks time frame for building a data pipeline. When you go to model development, depending on also what type of project or product you're building, your model development might have 3 weeks. Then your model deployment and monitoring will have 5 to 6 weeks. So that we will give you that time frame, but it will be different. So it becomes a scoping, data, modeling, and deployment. So these are 4 steps that you need to keep in mind. Now, let's start with a case study, a speech recognition. Okay, so someone comes to you and says that, okay, you know what, I wanted to build a platform for me for speech recognition. That means user will come to it and they speak, and then you detect the basically language, right? So step 1 is scoping, is your job. Let's say you are a consultant firm, and your job is to scoping. Well, okay, do I want to work on this project? Because someone comes to offer you money, you're like, do I want to work on it or not? Am I interested or not? But that's first question. Then the next question will, for example, will be that, well, if we work on this, for example, no, we don't have it here, but it's like, do we have data? Does the customer have data? Do we need to find data ourselves? Where does that come from and stuff like that? But also, like, what's the definition of success? Like, what are the metrics that we need to look for to decide if it's a successful model or not? And then part of the basically you do estimate the resources, how long this is going to take, how many engineers do I need, what's the budget, and you return that. You know, that becomes the idea of scope. And it's just an example of, let's say, voice recognition. Then comes around the data. Now let's say you have data. Now, the first question that you need to basically look is the data labeled? If you have a data that's not labeled, that's a much bigger problem, because who's going to label it? Right? Are we going to label it in-house? That means we have people that, let's say, we give everyone data. So my previous company, we needed to label data, and data was sensitive, and we couldn't do outside. So we had like about 50 employees, and every one of us got a bunch of data, and that would you need to basically spend 2 hours a day label the data, right? As part of your practice. And normally there are rules around data labeling. The rules is that, for example, if you can hire data labelers or raters on Amazon, Google, I don't know, IBM has another, but there are different platforms that basically you can manually label data. And you basically need to put rules around. The rules is that they basically labelers, or you can hire in a school. They will come on a platform, log in, and they start labeling. The rules is that, for example, do not label more than 2 hours a day. Right? Why? Because you get tired, the quality of labeling goes down. So you need to put a timer on it. After 2 hours, you will log out. Or maybe you can come back 1 hour morning, 1 hour afternoon, or something like that. You need to put rules around. And then the other one is that, is there label consistency? If you have label consistency means that if you hear to the same voice, right, same audio, and different people label it, is this consistent? And here in the example, for example, you hear today's weather, versus the other one is typed as today's weather. And the other one is like today's weather. They dropped right? That's not a consistent label. Your labeling should be consistent. That means that everyone agrees on that. So you need to ensure, what's the problem with that? Because imagine you have different audios and 3 audios, and you have 3 different labels. What does a model learn? An average among all of those, right? So your model technically learns an average, but between those 3 sentences, it decides to, in once 30% of time, maybe it says first one, 30% of time says the other one, and so on. Right? It's kind of like problematic. You need to decide on how much silence before and after each clip we should basically get, how to perform volume normalization and stuff like that. Those are things that you need to do, and we will talk about. Then goes around your modeling, and it's like this, you have a research team for modeling, and then you have a product team. All of that you need to keep it one thing in mind. In machine learning, the ML code is a combination of code, hyperparameter, and data. And that's the biggest challenge that industry had. We are really good in CI/CD and basically software practices, right? DevOps. We are not that good in MLOps, even right now, companies. Why? Because MLOps is not, so DevOps is the code. All you do is ops around the code. MLOps is the code, hyperparameters that use in the model and the data. You need to even keep track of the data to know which version was used as part of which model. If I want to retrain this model and new data comes, is this new data unique? What should I keep from the previous one? What should I add? Stuff like that. So the data is part of the ops. Data, code, hyperparameters. And then it comes again to deployment. Now, as part of the deployment for this study, which is a voice activation, like voice detection, right? You need to think about when we deploy this, where are we deploying it? So let's say this is an edge, basically you have this edge device like a cell phone. So when you work with Siri, right? Let's say who knows here, when you talk to your cell phone or to any of these basically like AI devices, how does it get activated to answer you back?
By a specific voice command. Keyword by a specific voice command.
So who's responsible for that special voice command?
The company that produces.
There is a piece, VAD, voice activation detection module, which is responsible for listening. When in like a Congress, they say that devices listen, and they always, if you think about this conversation that goes on, that's reality. Your cell phone is, if it's supposed to be activated, need to listen to what you are saying, and that's the VAD. VAD module listens for every 5 seconds and gets rid of the data. So it knows ahead of time if you are going to say Siri, because it's listening. If you just wait for, like, if you didn't have that and you say Siri, and the phone it didn't have that chance to detect it. So you actually have something on your phone that listens for every 5 seconds, 3 seconds, depending on the company, and that data basically just goes away. It doesn't save anywhere. So you need to account for VAD, and which is there's a microphone, there's a VAD, there's a front end, a speech, and so on. Why do you need to care for that? Because if you just think about your software, the product that you built is just the code, you will easily fail because you might deploy it, a customer deploy it on Apple, a customer deploy it on Samsung or something, and one of those you use during your training has a better voice activation detection than the other one. And that because of that module or the version of that module, or that easily that specific cell phone could not do a job on the software development. So for your end, that software development is not just code. For ML is code, and everything is in that entire pipeline. The device that you didn't build is part of your pipeline, because that could easily impact your model performance. So you need to account for those ones. Now, there's a estimate, at least by McKinsey, is that companies that they adapt this AI and ML, basically they will have 120% cash flows grows by 2030. And this they're always really good in this prediction. Why? Because they know that everyone wants to do this. Every company is looking for someone like you to come outside, and they know how to build things, how to put it all together. But the reality is that the operationalizing an ML is really difficult. It's really challenging. Because you can make it work, but it works even on a small deployment, but it might not even scale. So that operational part, it's basically challenging. Why? Because you have complex hardware, you have a data needs, you have basically model performance goes down. Again, fail silently, that's again, that's literally something that I'm dealing with these days, like a part of error that you don't see, like a silent error. And that basically requires you to add much more tracing and logging across the entire pipeline. So building a model is easy, managing the life cycle is difficult. That's the problem that companies have, or in reality we have. Now, I'm going to continue a couple of more slides and we take a break. When we want to talk between MLOps and DevOps, basically, DevOps is a practice that's proven. Everyone is using it in industry. So if you think about the history of before the concept of DevOps in 19 something, software engineering was having a hard time. It wasn't successful. Why? Because they didn't have CI/CD concept or DevOps. After that definition of CI/CD and DevOps basically introduced those practices, software engineering all of a sudden blew. Before that, it was actually a dead market. Because everyone tried to build the software, it's keep breaking and you don't know how, and as soon as you change something, it's still something else breaks and so on. Now, when it comes to MLOps, we basically extend the DevOps to machine learning, but you need to keep at the point. There's an ML system development and ML system operation. Now, the challenges that you have is you still have the same CI/CD problem, continuous integration and delivery. But then you have problems with data, models, code, and environment that it needs. That's where in CI/CD, in MLOps, has become CI/CD, CTCM. So CI and CD is the same thing, continuous integration, continuous delivery, but now you have continuous training and you have continuous monitoring. Because you just don't develop a model and deploy it and think it's done. If you don't monitor it, if you don't retrain it, it will break soon. Sometimes in a day, half a day, sometimes in a month. So if you think about it, just take one example, a stock market, right? The models that are being used in the stock market, how often do you think they retrain? Some companies, couple of seconds, some companies, depending on the types of the stock, could be an hour max. It needs to retrain as soon as possible. So if you work in a stock, basically development, and what you need to know is that if I need to retrain a model every minute, I can't use a large model. It should be a simple regression model that I can retrain it quick as possible. But then you might work in an industry like maybe e-commerce, that models retraining happens every 6 months or every year maximum. Then that's, it's a different, depending on the market that you will work, that retraining trigger is different. And this is assuming that this retraining happens based on your knowledge, not based on something detected wrong in the pipeline in the data. So that's continuous training and then continuous monitoring. That means that you need to monitor system 24 hours and have a proper engineers that responsible for those monitoring. If something goes wrong, and then you quickly could create a ticket, assign it to someone else. Why we do this? Because if there's actually two things. So if you deploy a model and basically you're doing the internal testing and something goes wrong, well, you contact basically the engineer, says that there's a problem. But if you develop something and you deploy it and now customer is using it, if error happens, that error, it's critical. You don't call to engineer, you call to whoever was working over the weekend. In the first scenario, you might come back next week, like, I'm going to fix it. In the other one, someone over a weekend is working, get a phone call, like, you need to fix it right now because customers are affected. So you need to know about the types of monitoring and how to detect them and who's responsible for what types of issues. And that's if we want to put it end-to-end together. So you have the basically development. As part of development, the output that it gives you is the gray box under it, is code repository, which is your GitHub, basically. Now, code that gives you some configuration and stuff like that, and you do training pipeline, that's your CI/CD. As part of the CI/CD, you have some artifact. Artifact, definition of artifact, we will learn later, is any input and output to your ML pipeline is called an artifact. Data is an artifact, model is an artifact, whatever is being produced, log becomes an artifact. So you have an artifact repository, and then you do continuous training. Training gives you a model registry, a place that you, as part of your retraining or training, you develop a model, you send it to this registry that versions and knows who created, what was the accuracy on it, what was the test score and stuff like that. Then you have a next step becomes the deployment. So now I have this model registry, and I have these models, and there's this one is the top model. Now I'm going to deploy that. The output of the model deployment basically is something that model that need to go to some serving infrastructure, and then you do serving and monitoring, and that also produces logs. All of those on top, you see something called ML metadata. ML metadata is a storage that your pipeline will keep writing to it. You can use whatever is written over there for debugging, for later retraining, and so on. So that's basically really important. You need to have that storage. It's either cloud-based or for your project could be on local on your machine. Okay. All right, let's take a break because we'll keep talking. We continue from there. Let's continue. Now, the next part, so that we talked about MLOps, which is what you usually see, and then we're going to quickly talk about LLM ops. Now, the first thing here is that what's the difference between these two, LLM ops versus MLOps? So MLOps in general is the practices that we want to manage, the ML product, types of machine learning models that are basically beyond within certain limit, within certain basically capabilities. They're not generated. When it comes to LLM ops, technically it could actually apply the LLM ops to generative AI of emails. It's not just LLM from the GPT perspective, but it has some unique challenges, and those unique challenges are models. First thing is that the size of the model. Models are super large. Right? In ML, you could have a model that you have multi GPUs and you use it, but when it comes to LLM ops, you normally by default have multi GPU pipeline, and you need to have proper pipelines and proper basically stacking. So have you any of you have worked with something like DeepSpeed? Or have you heard of something called like a G-pipe or a PyTorch pipe? So those are basically some frameworks that, let's say I have a model, and this model is really large. So if I have an 800 GPU, which with like 80 gigabytes of VRAM, I cannot load the model on it. I need 4 of those or 5 of those to even load the model on, not doing inference. Right? So larger models, that's the problem. So how should I put the model on multi GPUs? How should I break it into chunks? You break it into sequential chunks the data goes through. So those pipes, those like platforms, they do that for you. They help you with doing that multi GPU deployments. So that's one of the challenges that you have. Multi-stage training. Even for training, if you want to train a large, probably you have heard for GPT types of models, the large ones, you have hundreds of GPUs that they train for weeks. That pipeline basically goes for weeks. So if you think about it, it's not like you're running a model on one GPU, you train it, it didn't work, I train it tomorrow again. You train it once, goes through the end, and at the end, whatever you have, it's going to work. You can't have something it's not going to work, right? The cost that you went through, it's a lot. So you need to ensure that you understand that multi-stage pipeline for training. The concept of warm-up start, the concept of like adding checkpoints or some verification. And then after that, all this training is done, then it comes to something like a reinforcement learning. How to align this, how to ensure that I have a base model, but how to ensure that that base model can generate a result that it's, matching my expectation. Right, so those are becomes multi-stage training. And high compute and storage demands is another thing. Now, there are some core components. It comes around data collection and preparation. The first thing is that it requires a massive amount of data. If you're trying to train your own, you need to crawl internet, and then we talked about data poisoning and stuff like this. So you need to ensure that the data that you collect is at the end is something that you actually can use. Model development has multi-stage, as we see over there, is unsupervised, basically supervised and reinforcement learning techniques. So it's like a multi-stage in this training. Deployment goes across GPUs, TPUs, and then there's model management. So that means ongoing monitoring, evaluation, retraining. So that's something else that you need to do. Now, basically, LLM ops becomes best practices, tools, and workflow that you need around these larger models. It could be large language models, or it could be large like vision models and stuff like that. Now, by default is a subdiscipline of MLOps, and it's just kind of like a newer thing. So the tools that you will see, the concept that you will see is more recent and they're evolving. Like 3-4 years ago, MLOps was evolving, was pretty new. Now it's kind of like we have figured out which tools to use. But right now in LLM concept and the domain, there's so many tools in the market. Every company is trying to build the tools around it. And it's not that easy to figure out which one you need to use. It's kind of like that's more challenging. Now, why LLM ops matters here? Basically, well, if you don't have the proper pipeline, you could have unpredictable output, high computational costs, ethical risk. Think about this unpredictable output. If you haven't monitored the output of your model, it's kind of like an alignment. Your model could easily cause your company to go down, right? Get sued because the model said something wrong and that doesn't work. I think OpenAI is right now getting sued by that unfortunate event that I think this is there's a kid who did suicide, and then this model, the kid was chatting with this I don't know which one of the GPT models is that, and was talking about the thoughts and the stuff that they had, and the AI keep going with it. So it didn't have a proper alignment. So that could easily become a problem. That then, for example, high computational cost, you could easily build an application around these types of model. And if you have an account for the cost, in a month, your bank account could be empty. It's like the deployment cost is going to be a lot. Ethical risk is another thing. On the other end, the performance of these models normally are judged by humans. So you always have human in the loop concept to verify is good, is it bad, or something like that, right? So there is always some human in the loop. Even if you have heard probably LLM as a judge and stuff like that, but you still need someone else, a human, to come and verify these types of. Then your practices that you need to keep in mind: human in the loop, prompt management, safety checks. Those are like things that you need to keep in mind, especially for those of you that going as part of your project to work with LLMs. Those are things that you will need to keep in mind. Now, there are some similarity with MLOps, and they have shared areas, for example, from aspects of data set management, version control, CI/CD, CTCM. Those are going to be similar. The key differences, for example, when it comes in data, especially, it becomes harder to quantify or to measure if it's good or not when it comes to this generative models. Simple example is that if you have an image generation and you look at an image, or how do you decide is it good or bad? Right? If AI generate an image and you ask someone, do you like it or not? Is that a measurement? Like, is it good or bad? There are some strategies that you need to keep in mind. Does anyone of you know, if you try to build a vision model, how could you detect if it's a good generation or bad? What would you do? Like, what test comes to your mind?
Ask human.
And then?
Based on their model, based on their answer, we instruct the model to do accordingly.
So let's say you ask a human that is it generated by AI or is it real image, right? But how do you measure it if it's good or bad? There are some tests out there. One of them is that you ask humans and you measure how long does it take to detect. The longer you think, the better the AI. If I take 10 minutes on it and I'm like, okay, it's AI. Then AI is actually winning because it took 10 minutes for a human to detect that. It's a good quality, right? So that's one idea is that based on time. The other one is that you just simply ask humans and measure that's how often, like multiple humans see the same data and you see that how long it's gonna take, or basically how often they detect it, like what's the accuracy. So there are ways that you basically can detect that. That becomes human to do. You need to account for monitoring hallucination, toxicities, and stuff like that. That the output of your model, for example, a simple idea is that whatever the model generates need to have citation. If it doesn't have a citation, you don't return that response because it's going to be rejected. Then model adaptation is the next thing. But should I start from a pre-trained model, like, or should I build something? It's like a question. If you want to work with pre-trained model, what are the adaptation techniques that I need to use? And this is things we will talk about. Should I just do a prompt engineering, or should I fine-tune a model to some data, or I build a RAG pipeline? There's basically three concepts, right? The three techniques you can go. You either do prompt engineer, that means the model is there, I just change the way that I talk with the model. Or you basically build a RAG, that means the model is good, but I want this model to only answer with respect to my data. So I build something around my data, so my model only can respond with knowledge from my data. If especially you work with company data or proprietary data that you cannot send it to LLMs out there. And the third scenario, which is the fine-tuning, is that you're like, okay, you know what, this model is okay, but I have my own data and I want to fine-tune it with, I don't want to do a RAG for example. I want to basically fine-tune. There's some complexity around that. And then becomes infrastructures that require GPUs, optimization, cost control. It's just techniques like batching, response caching, routing to basically smaller models. Those are techniques that are being used in industry. And then you need to also keep in mind, don't always send everything to a large model. You can have much smaller models that they do tasks, and if necessary, it goes to larger models. Even the larger companies, they do that, like from ChatGPT to ThinkWater to Google. When you search, it's not like everything always goes to a really larger model. Maybe they're changing their strategy to it. But normally they have much smaller models that they do some tasks. Like you could easily find an answer by doing the regex instead of doing a call to an LLM. And if that didn't help, then you go to the next stage and so on. There's those models that can run much faster and cheaper, basically. And then monitoring purposes in traditional ML becomes accuracy and data and some other stuff we will talk about. In LLM, now you have the content that generate, because it's not just one number, acceptation, rejection. It's like a long text. It becomes the entire content. Is the hallucination? Is the bias? Is there any prompt injection? Did I detect that user is trying to manipulate the model or stuff like that? You need to always detect for all of this also. So in summary, MLOps for LLMs becomes whatever we see as we're going to learn as an MLOps in general, but also the workflows for prompt management, feedback, and some guardrails or the alignment concept. That becomes the idea of LLM ops that we will talk about. Now, you can think about it like this way. So on top, you have the data ops, which the ops that you do around the data, which is common between LLM and ML data. You always need to be sure that as data comes through, like one of you asked a really good question, asked the grade that what do you do with the data into a model? That's always a question. That's like, okay, what's my right on my data? If I want to go to a QR, maybe I want to be anonymous. I don't want to receive any email, right? Those are your rights. So you need to have ops around the data collection, data retention, and you need to have ops around data versioning. Who access what part of the data? Who can see the data? Should I anonymize the data? That means maybe you work in a types of domain it's sensitive. For example, if you work in healthcare, I worked 7 years in healthcare. One of the main problems you have is that hospitals first, they don't give you data. If they give you data, you need to prove that you removed every PII, every basically identifiable elements. Name, there are 18 PIRs defined in for healthcare. Like from social security number, phone number, address, name, and things like that. You need to detect all of those and remove. If you can prove it, maybe you can get the data. But that task is pretty challenging. You know, it's like because a name of the building could be a name of a human. And you remove it, then you don't know where that person went, which building they went to see a doctor. So you need to do all of this. That becomes data ops. Then you have the model ops, which is from feature engineering, embedding models, selection, pre-training, fine-tuning, whatever you want to do, all the way to validation and that continuation. Then when it comes to the DevOps on the left, so the gray is what's common across ML and LLM. The green is what's only for LLM, basically. So like basically the difference you see that they do experiment management and observability. So one of the things that you learn in this class and you will work with in your life is part of experiment tracking. Probably a couple of years ago, if you do experiment tracking, even I used to have this notepad that I keep track of my model by typing them manually. So I trained this model, the accuracy was this was that on this date, this data, or something like that. Right now, there are so many tools that can help you with experiment tracking. They automatically log it and then store that information. You know, if you work with machine learning, MLOps becomes tools like MLflow, for example. You know, it helps you with all that experiment tracking, or we have other tools like a cross tuner or stuff like that. They also do that. TensorBoard is something like that. When we go to LLMs like W and weight and biases, basically is one, for example, one of those platforms that you can log things and basically store them somewhere, and then you can track those. Then you have guardrails and model management. So in ML, you have just model management, but in LLM, you have that model management, but you also need to look at the output of the model and have a certain guardrails around. So it becomes some additive, basically, operation. Workflow, pipeline management, but then in LLM, you have agent and chain management. Because not only the model could generate text, but maybe the model needs to invoke some other model or calls to something else, do a search query. You know, it's kind of like those steps, chains, basically, the steps will be added. And then you have data management from your model output, and then you have infrastructure management, basically. So in general, you can think of like an LLM ops, the entire page that you see. The gray is common with the ML, and the green is additive and is only for basically LLM. You know, if you want to look at that separately. So this is basically this overall things that we talk about, but the steps becomes data collection, prompt engineering, fine-tuning or adaptation, LLM chain and agents, evaluation testing, deployment, governance, and security. Now, these are kind of like a broken down in quick recap, but I'm not going to go through all because we talked about so many of those. So data collection, we already talked about it. Prompt engineering and embedding, it's basically how to talk with the model or how you store the information somewhere and you retrieve it for your basically for your model, for your LLM. Then fine-tuning and adaptation is one of the things that you will have all the labs and this in details for these steps. How to fine-tune model, what are the good techniques that I can use, how could I make my LLM model that I'm trying to build or fine-tune more optimized, how to quantize it, how to prune it. You will have labs on those things to test out, to try your type of model. But one example is lower, kind of like a lower rank adaptation techniques. Then tailor your vocabulary, tone, or style, basically. That's quickly like another approach. Then LLM chain and agents is that when you want your pipeline to do multiple things. It's not one step. So basically you have different agents. You have one agent which kind of like a router. Request comes through that smaller LLM could just understand and based on the query decides, okay, this data should go to this pipeline. This data should go, or it could even like there are frameworks for that, like a framework like a React, you know, it's just basically You receive something, you reason on it, you make a decision, and you take an action over it. Or it could be just some sort of like other type of framework, which is like a planning, which the agents plan for things to be done ahead of time. So we will talk about those. And there are some frameworks or libraries that you can use. One example is LangChain, for example, but there are other libraries out there that you can use. So we will try to go over everything in details over time and have labs over those. But again, this is more new for us. So we don't have the same amount of labs that we have for MLOps compared to LLMOps. So then you need to have continuous evaluation with some structured rubrics, human reviews, and basically need to have some humans that every time you retrain the model, they need to verify it before that model goes to production. You can compare model versions side by side. You need to be sure you detect for toxic bias, factually incorrect. So you basically, if you work on something like this, you need to build a pipeline after the model. That's kind of like, if it passes this, then it goes on my scoreboard. And then a human comes and basically maybe verifies it. It's kind of like that. Deployment, serving, and monitoring. How do you deploy it? Do I deploy it as an API? It's a containerized service, basically. Is in a backend integration. What are you monitoring for? Latency, throughput, cost per request, cost per token. There's so many things that basically you need to think about if you work with this kind of like a larger models. Then that's why they're more complex. A machine learning model, it could be simply as like and what's the cost one API call? You have a model, you receive a data, goes through a pre-processing pipeline. But these types of model, the cost is per token. How long will it take for this model to run to answer this this query? That GPU hours that you go, that's the cost. What's the cost per token? What's the cost on average per query? And then you need to account for tracking the output quality drift, and then also have an approach for feeding back failures. The idea of here is that most of the LLM systems, you see that they have a simple thumbs up, thumbs down. You like the answer or not? So the easiest way is to try to collect user feedback. That's like a perfect labeling for your, later retraining. If user gives an answer, I don't like it or I like it, that's like the best answer that you could collect. I normally don't give any answer, but you try to collect it as much as possible. And again, another idea is that even if user didn't give you thumbs up, thumbs down, if they repeated the question, it means they didn't like the previous answer. Right? So you can do some sort of like an analysis of like a profiling of what they like, what they didn't like, if they didn't give you direct answer. And then the governance and security, control access to models and data, like who has control to it, who can see the data, basically. You need to ensure that enforce some compliances for privacy and safety standards. Like these days, if you go on platforms that they allow you to download open weight models, if you go on Hugging Face, for most of the models, you first need to say, I agree with the thing in order to be able to download that model. If you look at the agreement, there's a part that, for example, says that I will not try to reverse engineer or extract data from this model. Right, so you need to basically promise, just otherwise, kind of like you will be liable for that. Reverse engineering is it's a real thing. So if you give someone a model trained on a data without giving the data, and you just give them the model, they can reverse engineer to see whose data was part of the model. You make call to the model and look at the output, how confident is the model with respect to a token or with respect to a data. If the model knows something, like if you send my data to the model, it's like even classification model, not LLM. And the model is at 99% accurate, like I'm really sure, that means it has seen that data. The model is like a 40-60%, it's like there's a chance they haven't seen data. So you can infer whose data was part of which model. Now imagine let's say there's a model for detecting something which maybe a patient is not proud of it, and they don't want people to know that they have that certain disease. and someone goes reverse engineer, and basically they figure out whose data was part of it and they release it, or they basically start to do, it's part of the ransomware. Or it's kind of like you try to reach out to patients and say, I know you are part of this data and you need to pay me this in Bitcoin and something otherwise. So those reverse engineer things happen. So even as part of training, there are techniques that you can use, even if, like from large language model or even from general deep learning models, to ensure that the model doesn't memorize or is not getting sensitive to the actual data that was used during the training. You can perturb those gradients, because a simple way for knowing if the data was used in a model is to look at the model. So if you change a data enough and look at the impact on the gradient, if the impact is high, that was part of it. If the impact is low, that was not part of it. So you can adjust that gradient during the training as some practices that helps you to avoid something like that. TensorFlow, PyTorch, they have those implemented that helps you with this gradient manipulation. What was your question?
Two questions. One, so let's say if I change the PIIs in my data, right? And I use Faker to fake it and input it in the model. Is it gonna affect, or should we just, what's the best practice? Should we just remove the whole PIIs column, or should we fake?
So actually we will have chapters on this concept, data governance, but depending on where you are sending the data, the model. If you work in Europe, you under the EU Act, the model that you use should not receive any personalized data, like a name, address, and stuff like that. You should be removed, right? So you need to basically anonymize the data. Anonymization means that anytime there is a PII, you just put the star. I don't know what it is. De-identifying on the other end could be just simply just removing the actual name and replace it with different name. And so there's a concept of governance, like or like a policy of where you selling this one. From your model perspective, your model should not, the output of your model should not be sensitive to what's the gender or what's the race in the data, right? From for certain types of things, it's kind of like we're not, for example, talking about, I don't know, like maybe crime detection or stuff like that, that the maybe police department is talking about. Like you are trying to sell a car, your model doesn't matter who's the person, they should sell the same price. Right, so you can basically get rid of those or basically de-identify, but there's no direct rule of thumb that tells you that if you anonymize it, de-identify it. I think it's kind of like combination of things that you need to do.
All right, and another question is, let's say if I somehow reverse engineer the model, any open source model or maybe non-open source one, and then use that data to create my own. How is it recognizable that, how do they know, like, if I'm.
So that's what the OpenAI said about the DeepSeek, right? So the idea was basically what OpenAI said that DeepSeek did reverse engineer the data. And basically that means they made API calls and they collect the information. That's an idea of knowledge distillation. So there's a large model and you want to convert that large model into a smaller model. And let's say I want to build a smaller model that's only responsible for detecting, I don't know, cars description, or give me the car description. So every time I make a call to the larger model, I make a call about a car, nothing else, and I get the answer, right? Now, the answer that you get from those LLM models, let's say you get the probability of every word that was detected. So for every call, for every token, you have probability of words. Then you bring your own model, a small model, and you train it over the same data. The goal of knowledge distillation is that to ensure that the output of your small model as a probability score is as close as to the output of the large model. Yeah. So the only way that you don't need to access a large model technically, you just need the output of it. You give the same data over time, you train, right? So now I have a small model that was trained. But who can detect it? Well, depends. OpenAI, I don't know if they have a valid reason or not, but if they detect it, they could have looked at the logs of the calls that comes to the model and say that, okay, you called all these things and it distilled it into this model, I can prove. All right, so that's a way to do that. So if you make an API call, you're not invisible. They know what you call, they know your data. Right? So if you repeat over time, that's why there's also some, limit on the API rate. They can basically, it can detect that you are trying to do basically reverse engineering or knowledge distortion. Okay. And finally, what's the benefits of LLMOps? And it's all like everything that we talked about, but kind of like the performance, how to ensure that this large model that they have can work faster, less amount of GPUs, as can it scale? Like if I have lots of workload, it doesn't break. Then if you remember 3 years ago when ChatGPT came up, first 1 week it broke the website and couldn't basically answer to all the workload, right? So you need to account for those type of things. Risk reduction, proactive monitoring, disaster recovery. What's the problem of outage, for example, breach or disruption? You need to think about all of this. And finally is the efficiency. It's kind of like how can I accelerate the model iteration? First time it takes a while to develop a model, but you don't want every time that you want to retrain it to go through the same cycle. You want it to make it as quick as possible, as like a with minimum requirement from your engineer to come to the pipeline. You want to basically make that happen. So that's helps you. LLMOps helps you with that also. Now, best practices for the data management for your project. If you are trying to work with LLMs, think about data. You need high quality data. Think about that. Ensure your data is clean, accurate, relevant to the domain that you have. Manage your data efficiency. If you have a large amount of data, it's the management of it that need to be efficient. You cannot just put your data in somewhere super far from the storage. Super far means that it's in the storage in California, and every time you make a call from a GPU in Boston, that transfer still is not efficient. And so just keep them on. And have some rules for your data governance. Who can access the data? If it's the data that, for some of the teams, previous semesters, they got data from like Harvard medical data. So there are some I2B2 and then like this mimic data sets that you can use for medical applications. So there's not kind of like synthesize the identified real data by Harvard Medical School that you can get as a researcher, as a student. But when you want to get that, everyone in the team need to get some certificate called CT certificate of how handling sensitive data. And you need to write a request with that certificate and say that, hey, we only use this data for this. We don't utilize it to detect or reverse engineer or identify stuff like that. So you need to, based on that, know that who will access that data. If you have got the data, let's say if you have 6 members in your team, but 4 of you signed it or got the certificate, the other 2, they cannot see the data. Basically, otherwise you're liable on it. So just keep those in mind. And then for model training, decide on the right training strategies that you want. Should I fine tune prompt engineer? Should I create a RAG? Then think about like optimization strategies that you want to use, or libraries that you want to use also, which we will talk about those and have labs on that. And then for monitoring your training, decide on how you want to validate it. What are the strategies that, because it's really different from general machine learning models. The types of validation metrics that we use are different. So you need to also keep those in mind. And then again, for deployment, we talked about it to ensure that you have ideas around where to deploy it, how to deploy it, how to secure it. Again, we will break all of this down. And then finally, for the monitoring, just ensure that you know what to monitor for, and you know when to create a trigger, and you need to, when to detect if there's a retraining necessary or not. This is an example of how many of you here work with LLM, like build chatbots or RAGs and stuff like that? Okay, so we have kind of like almost half. So this is just an example of a RAG chatbot. The idea here is that on the left, here, you have documents, like let's say you go do like work in a company internship and they want you to build a RAG. So you have documents, and the first step for you is to convert those documents to text. Right? Those, let's say you got all these PDFs, and you need to convert them to text. So that becomes your step one. That itself, if you have worked with PDFs, you know it's a really challenging process. Right? I'm not talking about simply getting a paper PDF, giving it to at some of these libraries and giving the text. A real messy PDF is a PDF that has all this basic elements across the page, that when you convert it using these pre-built libraries, the order of elements will be random. Like the text won't be in the same structure or same order that you're expecting. So you can easily, at the really beginning step, you can convert the text or PDFs really bad. That doesn't matter how good is your RAG, your answer always bad, right? So that's one step. Then you need to chunk the data. Just you chunk it, you break it down to a smaller chunk, depending on the windows that you have. Even chunking, most of you probably have just done chunking based on a context window, like every 512 words. We did some sliding, right? What's the problem with those type of chunk? Anyone tell us? What could be the challenge if I just chunk?
We could miss probably a piece of data in between if you're not overlapping the data in between.
So the problem with just sliding window chunking is that you lose the context. Let's say you're reading a chapter of the book, and this chapter has a header, text, subheader, text, subheader, and so on. When you just do chunking like that, you don't know which subheader belongs to where. Right? So you need to basically do some sort of like a document-aware chunk or context-aware chunk, that you know this chunk belongs to the previous subheader, the previous subheader belongs to the previous header, things like that. So those are itself is really important for retrieval, because user wants to have a question and similar text might be in a different page, different chapter, and you can easily get the wrong result. Then you convert that into some sort of embedding using one of these pre-built embedding models. It's stored into a database. Now you have this database of every chunk becomes an embedding. We work with OpenAI or any of these models basically to generate answer. But user comes, ask a question, you convert that question into some embedding. You query that embedding against that database that you have, find the similar result chunks that you basically retrieve. And that retrieval also, we have different strategies for the retrieval. And then you get that retrieved answers, like maybe 5 different chunks came out, plus the user query to another model and says that, okay, this is a question, these are the knowledge that you need to know, provide the answer. So that becomes like whatever you give as an answer, right? So if you think of your project, you want to do something like that, you need to expand on it. It can't be just this, okay? It can be just chatbot. But when it comes to MLOPs, this you need to look at this separately yourself. You can't read it here. But these are all the steps that you will go through, from left LLM selection to data integration, fine-tuning, in context learning, reinforcement learning, RLHF, prompt engineering, context management. This is probably, I don't know if you have heard, is really important. Context management means that if you have the best prompt also, in order to understand why an LLM make a mistake, look at what you provide to LLM. That's the context, right? Put that in front of yourself and see what you will give as an answer. That's I think forgot the name of the person. One of the talks that I saw that forgot the name of them. Yeah, no. But they were talking about like what they do, that in order to improve the agents, they do this internal feedback, that wherever the agent fails, they bring that context and they pass it to engineers without knowing, and they try to see how they will answer. And if like engineers fails also, whoever answering fails, then they also like, it's not a good context. But if human can answer it, then the AI didn't know how. So then you have model performance monitoring, model governance, model security. So all of those names that we see under it, those are the companies right now in the market that you can utilize the platform for that step. Okay. I don't know which one of them are free, open source or stuff like that, but you definitely can figure out some. And then on the bottom, you have model architect optimization. We have integration, model selection, conversion, and then routing, runtime accelerator, GPU optimization. These are things that when it comes to LLM ops, you need to keep this in mind, all these components, because it's not a straight pipeline. It has so many components from model, data, training, fine tuning, and even to deployment. You need to keep that in mind. And then I leave this one for yourself to read. It's from Gartner. It's really interesting, which it's basically explanation of what you see here. Okay, so I leave it for yourself to read it and what basically I went over. All right. Now, so for the course outline, basically, we break the course in 4 sections. Scoping is going to be the first, basically 2 classes. Then you have data, which is going to be about 4 weeks of the content. Or 4 or 5. I think 5 because of the LLM data. Then we have modeling, which is 2 weeks, and the rest goes to the deployment. Okay. And then what you will basically see is at end of every basically page or PDF, we have the lab and the assignment. So this week you won't have the lab. We are combining some of the labs next week. So it becomes one large lab class. So next week is just going to be labs. We have a series of labs that you all need to do or to know before we continue for the project, which just comes around the CI/CDs, logging, and API creations. Okay, not API calling, API creation like fast API, Flask, stuff like that. Okay, so next week is going to be lab class basically, and then you will have a paper at the end of the PDF, which I highly recommend you to. They're easy paper. You're not math paper. Just skim through. At least get the sense of the challenges or what's being taught inside that paper. All right, let's continue. So, the first thing we're going to talk about now is data and concept drift. So I said today a couple of times, you will have drifts, right? But what is a drift, and like what's the definition, and how can I detect it? So think about this. Data drift is when you have data like this distribution, as you expected distribution for the data, but in production you're receiving this distribution. That's where there is a drift, shift basically happen in the data distribution. And your goal is that to detect this early enough, otherwise you totally pass a wrong data distribution. Now, think about this. You have this pipeline for your model. So I every time basically have this pipeline that is, let's say this is the model accuracy over time is going down. Okay, that's the idea of monitor. You monitor this and you're like, okay, and then you have some sort of like a threshold, and maybe the secondary threshold. So this threshold, this could be a yellow, like kind of like a warning. And this threshold is red. If we reach there, drop that accuracy, and this model should be removed from the show. So you have this monitoring pipeline, and then you measure things, and you can detect, well, I reached to yellow. And then you can basically guess, how long did it take, for example, for me to reach to yellow? It doesn't necessarily need to be time, but for you, like in a month, right? And then let's say I fit some sort of like a linear regression to this. how long will it take to get to here? But based on this interpolation, based on what I can see, it's gonna take another 2 weeks to get here. And you're sure about it, this model performance goes down. And that's where you trigger a retraining pipeline. The idea here is that model performance over time will go down. You can't do anything about it. The idea is how to control it and make it slower. I don't want to retrain drop this model and go to a new family of model every other month. So you have this, when it gets here, you say, okay, trigger a retraining pipeline starts, and you have a new model. Over time, you will finally go down, but you make the process slower. So every month, whenever there's a detection, you just retrain the model, improve it, goes for some other time, and retrain it, improve it. And it gets to the point that the retraining doesn't work, and that's where you do generational change. Like maybe we can't use this model, we need to make it a bigger or more smarter model. So that becomes the idea. And that's definition of model decay. The performance of your model over time decays and goes down. The performance as source of like accuracies or prediction, not performance of a system performance. Is that clear? Yes.
Over time, as we like gain more and more data, shouldn't the performance improve in that aspect?
So if your model is static, your model doesn't retrain with every data point. That's really costly. You only retrain. So the retraining ideas is that you either have a timeline retraining. That means doesn't matter how good or how bad is my model. Every 6 months, every 3 months, we go through a retraining pipeline. The other idea is that you monitor something like that and you retrain. But you cannot just have a continuous retraining because it's called and it's ineffective. So you need to detect it and do it. So why model drifts? Why that will happen? You know, if this model is pretty good and we had a 99% like a test accuracy or like a score, like why this drift happens? And the drift happens mainly for three ideas: data drift, concept drift, or both are the same. Majority of time is the data drift, but the concept drift also happens. We're going to talk about it. So data drift is when the distribution of basically data is changing. So in this example, during the training, the data that you have, majority of the data comes from paid search. So you paid online for search and people clicked on your data and then that's the data you collect. When you stream the data, you are not receiving the same type of customers. Your data comes through different distribution, different types of customers. So there's a shift into distribution of people who click on ad versus people who just curious or they want to use your platform, right? So that drift in the data, in the distribution of the data or the cohort causes problem that your model performance will go down. Another example is this, like if you think about the age group and the age group all of a sudden changes, increase in mean or basically a standard deviation change, that also will cause that, you know, your model performance to go down, to decay. Now, there's a terminology, training serving skew. Training serving skew, basically, it's when you build a model, works really good. The moment you deploy it, the same moment, not a week, not a day, same moment you deploy it, the model breaks. Like it breaks, basically the performance is super bad. That terminology called training serving skew. What does that mean? That means your model is kind of like overfitted to that training cohort that you have, which that data distribution also is not a realistic data distribution. So, and an idea is that your company is building an app and your goal was to sell it within US. All of a sudden, last minute you change, let's sell it to Europe also, right? But you didn't account for that data. The moment you open the market, it breaks. Like it is, the performance is really bad. That's called training serving skew. Okay, so you can think of it this. Drift is when things gradually drifting. A skew is batch. This batch versus this batch is not a drift. As soon as new batch comes, it doesn't. So batch versus SKU versus drift. Now, the other one is concept. Now, concept drift is kind of like a bigger picture to keep in mind. So concept is labeled why, that target value that you have, that's the concept. So concept drift is an example again, if you think about it, like a ballerina shoes. Maybe if you 5 years ago would have gone search for ballerina shoes as sports shoes, wouldn't come as a sports shoes, but now it's considered as a sport. It's like a part of the Olympics, right? So you see, that's a concept change. How something is basically being considered. That could happen gradually, could happen suddenly. An example of concept drift is that in a basically gradual is when things over time, like the fashion over time changes. That's a concept drift, but it's gradual. But sudden is, best example is during COVID. That was a sudden concept drift. Anyone can guess or give us one idea that you know during COVID happened?
Shift to online platform.
Like more specific. Zoom. That's a great one. Which one impacted you? Credit cards. When COVID happened, most of the credit card companies had issues with detecting what's a fraudulent and what's basically accepted transaction. It's possible for you to receive an email that you try to spend card and it's basically send you a text. Did you try to do this? It's like a simple transaction you were trying. So data scientists and machine learning engineers who work in banks on these credit card companies, we were one of the earliest one to update their models when COVID hit. Because whatever model that they had all of a sudden concept change, everything that you were assuming to be fraudulent is no longer fraudulent, right? So that's the sudden. Another example is in online shopping, right? So companies, they stock based on what you think people will buy. One of the biggest change is here. Sell of yoga pants, right? So yoga pants had a surge of 350% during COVID. That means every time you go on a market, they didn't have anything for you to order because companies didn't stock. They modeled the predictive model that you have tells you how much to buy to stock wasn't working. So that becomes a sudden change in the concept. You know, because again, could be it's something that is slowly, gradually changing, or it could be something like suddenly changing. Okay, so that's gradual. How fast a model age? There is no technical rule of thumb for it, but there are ways that you can kind of detect how fast my model kind of predict and interpolate that, like how long will it take before I change this model or before I need to update. So I can account for it ahead of time.
I wanted to talk about the sudden change, concept change, and so if we don't, let's say if we are having a sudden concept change, right? So you mentioned that some of the companies retrain their model suddenly to, adapt with the thing. But how did they get the data of that specific environment or what people are going through to train on? What are they training on if they don't have the data?
So they do have the data. But the banks basically, when you use credit card, they know, okay, you're basically what was your previous transaction was in Boston. Where's the new one? It's a weird one. You never shopped this item, but you're still in Boston, right? So that there are some models basically they look at the log of data, or they send you a text and says that did you try to make this purchase? And you say yes. They collect that feedback. So, but it's also wasn't that straightforward. They need to basically account for certain things to update that model. Right. But that's why you need to have a log and traceability. It's part of your data collection.
Got it.
All right. So And this again, this was the sudden concept drift which we talked about. And now the next question is dealing with the drift. It's come back also to similar to what you said. If I had a drift, what should I do? Okay, I'm wanting to retrain my model. Should I get rid of the previous data that we have? Should I just bring a new data, or should I just totally dump the model, or should I continue continue training of the model? So if you work, for example, with neural network models, you have a checkpoint, right? So next time you could continue from that checkpoint, like a previous knowledge as a base model and train from that point, or should I just start from scratch? Those are type of questions that you need to figure it out. But depending on the how much was the impact? What was the impact? If my entire data is useless, then you need to start from scratch. If only portion of the data is useless, and I have a new data, so you get rid of that portion and add the new data. Then in that scenario, I don't need to start from scratch. I continue basically retraining the model by feeding to the model, like in every batch data that goes to training, like maybe 70% of the new data and 30% of the old data, so the model doesn't forget what it was trained over. So it's kind of like you continue training the model. It's all again, it's all like it also has some business rules, like some decision making that you need to decide. Should I retrain it? Should I dump it? Should I start from scratch? Those are type of things that you need to keep in mind. And then the last one is recurring concept drift. The types of drift that are seasonal, every season will happen, the concept will change, and you need to account for it. Every season around the spring break, airlines knows they need to jack the price because the demand goes up. Around the Christmas time, that's the same thing, right? So because the demand goes up, so if you don't account for that, then there's a problem. So companies basically, they know when, based on the patterns that they have seen, there will be some demand, and you account that in your model. Think about you building a simple regression classification model, and all you need to do, like simplest way, add one column. It's binary, and this basically says seasonal. If it's yes, means it's a season for a high, like a surging the price, like maybe Uber, and 0. And this will has a weight. If it's yes, that weight multiplied by that plus the rest of the pipeline, right? If not, it doesn't have any impact. Right? It's just a simple idea. Like you can just add something that accounts for that seasonality changes. All right. So we're going to stop here because I know you guys are like tired. But before